In this period, we will talk about integration by parts and apply it. Rule: integral of u times v prime dx equal u times v minus integral u prime times v dx. This rule is called integration by parts. Integration by parts can be used with the following case. When we have integral polynomial times len g of x, then we use integration by parts. In this case, we take u equal len g of x and find the derivative of u, and choose v prime equal polynomial and find v, which is integral of this polynomial. Application: calculate integral x len x dx. Here we have integral polynomial times len, so we must apply integration by part. Solution: let v prime equal polynomial which is x, so v equal integral of x, which is x over x square over 2, and u equal len x, so u prime equal 1 over x. Then integral of x len x dx equal u times v x square over 2 times len x minus integral of u prime times v minus integral of 1 over x times x square over 2. Simplify x square by x, we get x over 2. And integral of x is x square over 2 times 2, we get x square over 4 plus constant c. Try to solve integral len x dx by the same way. 5. Define definite integral and identify some of its properties. Let f be a continuous function on a closed interval a, b, and let g be an antiderivative of f. Then the integral of f from a to b is integral from a to b f of x dx equal g of b minus g of a. Note, integral from a to b f of x dx belong R. Example: integral from 0 to 1 2x plus 1 squared dx. This integral is of the form ax plus b power n, where a equal to 2. So apply the rule, we get 2x plus 1 power 3 over 6. Then we don't put c here, we substitute x by 1, we get 27 over 6 minus substitute x by 0, we get 1 over 6, so the result is 13 over 3. Another example, integral from 1 to e x len x dx, as we saw, it's equal to x square over 2 len x minus 1 over 2 x square over 2. So substitute x by e, we get x square over 2 minus e square over 4, minus substitute x by 1, we get 0 minus 1 over 4. So the final result is e square over 4 plus 1 over 4. Here we have some important properties. Integral from a to a f of x dx equal to 0. Integral from a to b f of x dx equal minus integral from b to a f of x dx. Integral from a to b alpha f of x dx, alpha belong R, equal alpha integral from a to b f of x dx. Integral from a to b f of x dx equal integral from a to c f of x dx plus integral from c to b f of x dx, where c belong a, b. If f of x greater than or equal to 0 over a, b, then integral from a to b f of x dx greater than or equal to 0. If f of x less than or equal to 0 for x belong a and b, then integral from a to b f of x dx less than or equal to 0. Also, if f of x less than or equal to g of x over ab, then integral of f less than or equal integral of g over ab. Now, if f is an odd function, means f of minus x equal minus f of x, then integral from minus a to a f of x dx equal to 0. If f is an even function x, then integral from minus a to a f of x dx equal to integral from 0 to a f of x dx. Example: applications on odd and even function. Example 1, integral from minus 2 to 2x cubed plus x dx is equal to 0 because here we have integral from minus a to a, so we must take f of x equal x cubed plus x, and find f of minus x, which is equal to minus f of x, so f is odd. Then by applying this rule, we get integral of from minus 2 to 2 of this function is equal to 0. Another example, integral from minus 1 to 1 x squared plus 1 dx. Also we have from minus a to a. Let f equal x squared plus 1. Then f of minus x equal f of x, so f is even. Then this integral equal 2 from 0 to a, which is 1, x squared plus 1 dx, and integral of x squared, x cubed over 3, and integral of 1 is x, and then we substitute by 1 minus by 0. The final result is 8 over 3. Homework, exercise 2, parts 1 and 2, page 56 from Mastering book. Exercise 2, parts A, B, page 207 from Building Up book.